Welcome friends. In the last video we have seen set implemented classes, and we have gone through the linked list hash sets uh, or many set classes we have gone through in previous video. If you don't watch that video, go on the channel and watch. In this video we are going to see list implemented classes. List is an interface in Java. It is a child interface of collection. If we want to represent a group of individual objects where duplicates are allowed and insertion order is preserved, in that case we can go with list objects. As we have seen in previous video, set doesn't allow duplicates, whereas list allows duplicate. So, our when we want to preserve insertion order means like objects are added in that order only. We want to store into the list, then we can go with the list, and we can preserve insertion order, and we can differentiate duplicate object by using index. Hence, index will play a very important role in the case of list. There are several methods provided by list, which are we are going to see, and we are going to see some of the example as well. So let me, you guys, here I have prepared one PPT for you guys, like the list. In this PPT we are going to see different use cases as well as real-time examples. So stay with me and of this video, so you will have crystal clarity on each things in list. And similarly I have given some real-time example and uh, when to use which sets in previous video as well. Similarly, in this video also I'm going to explain you guys same. So let's get started, guys. The Java collection framework offers different list implementation, and as well as array list, linked list, vector, copy on write array list. So we can use this data collection to as per our requirement, and when to use which collection we are going to see here. Let me go through next slide. Array list. First, we are going to see array list. So when we compare, go with the array list, it is flexible and efficient. Means it is automatically resize, and elements are added or removed in array list. And it is means we can array list is resizable and growable in natures. So duplicate objects are allowed inside array list. Insertion order is also preserved. Heterogeneous objects are allowed here, uh, uh, and null insertion is also possible in array list, as well as here copy on array list. It is like thread shape collection of array list. This we are going to see in further slide videos. And next, linked list. When to use linked list? When element are stored in doubly linked list, like it is adding or removing efficiency insertions. Means whenever we are trying to retrieve element in the middle of the list, in that case it is efficient this data collection. So we can go with list, and it supports both queue and stacks operation. We are going to see some of the example as well in this. So first I will let you guys go through one example in which we can see ArrayList example first. Here I have created ArrayList object in which I am going to add some of the element and I will try to print that element. Next we are first ABC I have added. L dot add 1, 2, 3. Next L some null also we are trying to add here. L dot add null elements. We will print this array list. And some operation we are going to perform here, like L dot remove method is there in second position element we are going to remove here. And then again we are printing this array list. Next operation we are doing again add at index position L dot add. So second position we are going to add our next element XYZ. And then we are again we will be printing this array list. Let me run this program, guys, and we will see the output what we will get. I will try to explain. Here we can see first we have added 3 element inside array list, and that 3 as null is allowed. So ABC 1 to 3 and null. Then we have printed. Then we remove second position. Second position we have removed means from the list null is removed as 1 to 0. Our index start from 0, 1, 2. Then second time it is printed ABC and 1, 2, 3. Then the next time I have added L dot add at 2 means second position inside array list we have added XYZ. So it is printed XYZ. The array list it increment it default initial capacity of array list is a 10, and whenever it's reached to its limit, new capacity is equal to added current capacity into 3 divided by 2 plus 1. Like this new element added into the array list. Next we are going to see our linked list. Also linked list we have check. Then vector is a synchronized collection. It is a thread shape. All operations are synchronized, ensuring data integrity. And so it is a legacy class, and here we need to, like, every method present inside a sync vector is synchronized, and at a time only one thread is allowed to operate on vector object. Hence vector object is always thread shape. Where we can consider a vector object is a thread shape. Relatively, performance is low as compared to the ArrayList because thread are required to wait. So we and it is a legacy class. And the copy on write ArrayList, it is a copy on or it is a thread shape collections. Either in array copy on array lies like iterator don't throw like concurrent modification exception when multiple threads trying to allow to acquire lock on the objects. And when to use each list implementation, like here we can see array list, general purpose list with fast random access. Whenever any element we want to access in fast manner, as it underline implements data structure as a random access interfaces as well. So it is faster than linked list and vector. Linked list is optimized for sequential access and efficient means insertion and deletions. Means our requirement is insertion and deletion in the middle of the list. In that case, we can go with linked list. Vector and copy on write array list. As I told previously, it is a thread shapes, and when we are trying to one thread is trying to acquire a lock on another thread. In that case, copy on write array list doesn't throw concurrent modification exception. So in that case, we can go with these choices: vector and copy on write array list. Here the access times given random for a release, it is constant random access, or copy on write a release maintain high read performance under concurrent access. Whenever go with concurrency, in that case we can use copy on or write a release. And linked list is excel in efficient insertion and deletion operations. Next, some of the real world use cases here given. ArrayList for database caching, like fast access of cache records, and your linked list for efficient queue-based packet processing. In network packet buffers, so we can use linked list concurrent data structure. Copy on write ArrayList is a concurrent data structure, which is a thread shape, and ArrayList for managing and rendering game objects. Here given some choosing a right list, when to use which requirement. For that we can go first define requirements, understand your application needs, access pattern, concurrency and performance. And then we can choose to our optimal list collection, whichever we want. From here key takeaways is like ArrayList, it is a flexible, efficient, and for general purpose list we can use ArrayList. And some of the features I have already mentioned, like ArrayList, it is a uh, insertion order in it is pressure in this duplicate objects are allowed, and heterogeneous objects are also allowed. Linked list is like optimized sequence access and fuse stacks. Vector, it is a thread shape, may have performance impact. And copy on write array list, concurrency friendly with no blocking reads. That's from this video, guys. I hope you get gain some knowledge from these videos. So subscribe to the my channel. Thanks for the watching videos. Thank you, guys.